Alright guys, so this is the first makeup lecture, Math 99, and we're going to discuss section 8.4, which is about solving applied problems. If you remember, we had systems of two equations with two unknowns, linear equations with two unknowns, usually x and y, and now last time we discussed the geometric sense of the system of equations, namely it's like when you have two lines and solving the system means finding the intersection of those those two lines. Now there are a lot of real-world problems that have mathematical model being exactly the system of two linear equations with two unknowns, and that's the topic of this section. Okay, so let me read first problem for you. So it's an example number 2 from the section. So I'm reading the textbook. So it's called Blending Flower Seeds. Tara's website, called Garden Edibles, specializes in the sale of herbs and flowers for colorful meals and garnishes. Tara sells packets of nasturtium seeds, whatever nasturtium seed is, whatever that flower is, for 95 cents each. So one packet of nasturtium seeds is 95 cents per packet. So also she sells so-called Johnny Jump Up seeds for $1.43 each packet per packet. So she decides to offer a 16 packet so-called spring garden 16 packet mixture combining packets of both types of seeds, and she wants the average cost of a packet in that 16 packet box to be $1.10. So the question is, how many packets of each type of seed should be put in her garden mix? Okay, so she wants to create a box with 16 packets. Some of these packets should be nasturtium seeds, some of these packets should be Johnny Jump Up seeds, and the total cost per packet should be $1.10, and also these are the prices of each flower packet. Okay, so let X be the number of nasturtium seeds. So X is number of nasturtium seeds. Nasturtium packets in this spring garden mixture, okay? And let Y be the number of Johnny Jump Up, so let me say JJU packets. Okay, so the question is, what are X and Y? That's the question. How many packets of each seeds or of each flower should she have in the 16 packet mixture? So there are two requirements that we can immediately see. First requirement, or first condition that X and Y satisfy, is that the number of packets is 16. So on one hand, the number of packets is X plus Y, the number of packets in the mixture, and on the other hand, that should be 16. So the first requirement is that X plus Y is 16. Okay, what about some other requirement? Well, the other requirement is that the average cost of packet in this 16 packet box is $1.10. Okay, now we can tell if you have X nasturtium packets, you know exactly how much they cost. They cost X times $0.95. if you have Y Johnny Jump Up packets, then they in total cost Y times $43 dollars. And so when you add them up, the total cost should be, if the average packet costs $1.10, the total cost should be $1.10 times 16. All right, so that's the requirement. So on one hand, we know, or we have X times 95 cents plus Y times $1.53. So that's actually the total cost of taking X packets of nasturtium and Y packets of Johnny Jump Up. But the total cost should be 16 times $1.10, because in that case will Tara have that average packet in the 16 packet box will cost $1.10. So we set that requirement that this thing should be 16 times $1.10. And so now we just need to solve this system in one of the ways that we discussed earlier. So one way is by substitution, the other one is by elimination. So in this case, we can use substitution because coefficients of x and y here are 1. So let us express y in terms of x. So we have that y is 16 minus x. Okay, so we plug that in here. So we have x times 0.95 plus, and y is 16 minus x times 1.43. That should be equal to, this thing here, 16 times 1.10. Okay. Now we just need to solve for x. So to solve for x, we want to have only x's on the left and everything else on the right. So to do that, we will multiply this out first and have x times 0.95 plus, and we have 16 times 1.43 minus x times 1.43. That should be equal to, and 16 times 1.10 is 16 times 1 is just 16, and 16 times 0.10 is 1.6, so this is 17.6. I could also compute this, but I don't have a calculator with me. I just want to solve for x, so I take I keep this guy and this guy on the left side of the equation, and and move this one to the right side of the equation. So what I have is, I can pull out x, so I have x times 0.95 minus 1.43. Okay, that should be equal to this 17.6, and when I move this guy to the right, I have minus 16 times 1.43. Okay. Now to find what x is, I just need to divide by this quantity. But what is this quantity? Well, this is I need 0.05 to 1, so this is negative 0.48. So I have that x times negative 0.48 is 17.6 minus 16 times 1.43. Again, I'm not simplifying this just because I don't have a calculator. I mean, I can calculate on computer, but let me not waste time. To solve for x, just divide by this quantity, and well, okay. Let me say what this is. I will just take a calculator. Just a second. Okay, so the calculator says that this guy here is minus 5.28. So we have, let me write that here. That x is x times minus 0.48 is equal to minus 5.28. Okay, now we want to find x, so we divide by negative 0.48, and we get that x is negative 5.28 over minus 0.48. And with use of calculator, which I just did, we get that this is 11. All right. So there, Tara needs to take 11 packets of nasturtium. Now, to see how many are we done? Well, not we are. No, we are not done. We still need to see how many Johnny Jump Up seed packets should she take in the 16 packet box. So we have that the total number of packets should be 16. So if she takes X packets of nasturtium seeds, she needs to take Y equals 5, right? Packets of Johnny Jump Up seeds. So in general, if you have some more complicated calculation to do, you just need to use the other equation. So x plus y should be 16. So if x is 11, we have this, and then you need to solve for y. In this case, it was so easy that you didn't need to do any extra work. Just as soon as you see that x is 11, you know that you need 5 more to get 16. All right, so 11 packets of nasturtium, x is 11, and 5 packets of Johnny Jump Up seeds will make a 16 packet box in which the average cost of the packet is $10. Okay, so that's the first problem in the text. Now let me do next problem. Let me read the problem for you. So here is another example. It's example number 5 in the textbook. It's called auto travel, and it goes like this. Your brother leaves your home on a trip, forgetting his suitcase. So suppose it's something important. You know that he normally drives at a speed of 55 miles per hour. You do not discover the suitcase until 1 hour after he has left. If you follow him at a speed of 65 miles per hour, how long will it take you to catch up with him? So here is the picture. So your brother travels at the speed of 55 miles per hour, and suppose here is your house and here is his suitcase, and you are just about to leave when he is already, so that was 1 hour after he left. So when you are just about to get into your car and try to catch him, he is 55 miles far from you, because 1 hour already passed and he travels about 55 miles per hour. So here is your brother in the car. I don't know, something like this. Your brother. And so he already, so let me say, this is suitcase. So the distance from here to here is 55 miles after 1 hour. And now you leave and you're trying to catch him, and you travel 65 miles per hour. So you have, you travel faster, so eventually you will catch him. But the question is when? How much time will it pass after that first 1 hour? So how much time will it pass after you get into your car until you catch your brother and give him his suitcase? So here is the thing. What's the distance that you traveled after T hours of traveling? So your speed is 65 miles per hour and your brother's speed is 55 miles per hour. And the question is, after T hours, how much you're going to travel. So if you travel exactly 1 hour, the total distance from your house that you travel is going to be 65. If you travel 2 hours, it's going to be 2 times 65, right, which is 130. If you travel T hours, it's going to be, if you travel 3 hours, it's going to be 65 times 3. Or in general, or let's say if you travel half an hour, the distance you traveled is going to be half of the 65. So in general, if you travel T hours, you are going in total to travel 65 times T, right? So that's the distance you make after T hours. So that's U. Distance that you travel, D sub Y. Now what about your brother, D sub B? How far he's going to be? So when I say distance traveled, I mean distance from from your house, okay? From the point where you took off. Now, after 1 hour, he's already going to be 50 miles far from you. And since we start measuring time T when you left your house, so that means initially he already has 55 miles being far from your house, and if 1 hour after that expired has passed, then he is going to travel 55 miles more. Or if 3 hours after that first hour has passed, he's going to travel 3 times 55 miles more. In general, if T hours passed after you left, he will travel during that time, he will travel 55 times T miles, but he also has the additional 55 miles that he traveled during the time until you realize that actually he left his suitcase. So his total distance from your house is not going to be 55T, it's going to be 55T plus 55, okay? Now the question is, what is time T so that the distance you travel from your house and the distance that your brother traveled from your house is the same? So that's the point where you will catch him, All right. So for what? So this we are looking for the same distance. So dB and dy should be the same. So for what value of t is this going to be the same? So instead of writing dB and dy, we are just looking for d, for which at the same time it should be equal to 65t and also should be equal to 55 plus 55t. Okay, so again, this is the system of two linear equations with two unknowns, d and t. And our question is how much time it's going to pass until you catch him. So, and you can also wonder how long you are going to travel until you catch him. So it's easy here to solve for t, namely just substitute d is 65t, substitute that in the first equation. So we have 65t is equal to 55 plus 55t, all right? And we just need to solve for t. So we can move 55t to the left, so you have only t's on the left, and the rest is on the right. So when you move 55t to the left, you will have 65t minus 55t. Well, that's going to be 10t, okay? And that should be 55, okay? So that is going to be for t equals what? Well, you just need to divide by 10. So 55 divided by 10 is 5.5 hours. So we talked about hours, time is in hours, distance is in miles. So it's going to take you 5.5 hours. That's a lot, right? But maybe it's so important that it really it is really worth it. Or if it's not worth it, so if you cannot travel faster than this, suppose that's the speed limit along the entire trip, then maybe if you calculate this quickly before you take off, and when you realize that it will take 5.5 hours, maybe you will decide it's not worth it. Maybe his suitcase is not so important. Okay? And if you wonder how far you will travel, maybe if you want to calculate how much gas you are going to spend, so, or waste. To see how far you need to travel, you just calculate d is 65 times 5.5. So that's going to be, so 65 times 5.5. Well, what's 65 times 5? Well, it's 325, so it's 325, okay? And 65 times 0.5, it's just 32.5. So if you add these two guys, you are going to get 357.5 miles. So this is going to be the distance that you need to travel until catching your brother, is going to be 357.5 miles. That's a lot. Okay? All right, let's see next example. Okay, here is problem number 7 at the back of section 8.4. It's called catering. Stella's catering is planning a wedding reception. The bride and groom would like to serve a nut mixture containing 25% of peanuts. Stella has available mixtures that are either 40%, so that's one mixture that she has with 40% peanuts, and the other 10% peanuts. And the question is, how much of each type should be mixed to get a 10-pound mixture that is 25% peanuts? Okay, so bride and the groom want 10 pound mixture of 25% peanuts. All right. So we want 10 pounds of the mixture, and the mixture, so that's what we want. And the mixture should have, what did you say, 25% of peanuts. Now, the only available mixtures that are sold are 40% mixture and 10% mixture, all right? So we have 10% mixture, 10% peanut mixture, and 40% peanut mixture. Okay. Now it should be clear, since this percentage is lower than 25% and this is higher, appropriate mixture of these two should make, so appropriate contribution of this mixture and appropriate contribution of this mixture will make another mixture with 25% of peanuts in it. So, how are we going to do that? Well, the question is, how much? What is the amount of mixture 1? So let's say mixture 1 and mixture 2. So what is the amount of mixture 1 that we need to get or take, and the amount of mixture that we need to, or mixture 2 that we need to take in order to get, when combined, to get 25%, 10 pounds of 25% peanuts. So let X be the amount of mixture 1, okay, in pounds, since we have pounds here, so let's talk about pounds. So the amount of mixture 1, so that's X. Now Y is, by Y we denote the amount of mixture 2 in that combined peanut mixture. Okay, so the total amount is supposed to be 10 pounds. So our first requirement is that when you add the amount of mixture 1 and the amount of mixture 2, that sum should be 10 pounds. Okay? And the other one is that the percentages need to add up. Okay? So if you have X pounds of mixture 1 and the contribution of peanuts is 10%, you basically have X times 10%, we can write 0.1. So that is the amount of peanuts that we have in X pounds of mixture 1. Okay? So for example, if X is 1 pound, you have 0.1 pounds of peanuts. Or if X is 3 pounds, then you have 3 times 10%, so it's 0.3 pounds of peanuts. So the contribution of peanuts in that case, in those 3 pounds, is 0.3 pounds. Okay. Now, what about the other mixture? Well, if you have Y pounds of mixture 2, the total amount of peanuts that you have in Y pounds of mixture 2 is actually Y times 40%, and 40% is 0.4. So you have this amount of peanuts, which is a contribution of the first mixture, and this amount of peanuts, which is the contribution of second mixture. So when you add them up, you are supposed to have uh, 10 pounds of, you are supposed to have that the amount of peanuts is actually the amount that you will get as 25% of 10 pounds. So in other words, you want to have 10 times 0.25 to be your amount of peanuts in that 10-pound mixture. So you want this to be equal to 10 times 0.25, okay? So 25% of 10 is just 2.5 pounds. So if you have a mixture of, if you have 25% mixture of peanuts and 10 pounds, in 10 pounds you will have 2.5 pounds of peanuts, all right? So that's exactly what you have. You want to have 2.5 pounds of peanuts in this 10-pound mixture, all right? So these are two requirements, and so the question is, what are x and y? So again, we can solve this by substitution. So x plus y equals 10 implies that y is 10 minus x, so we can solve by substitution. So we substitute y in terms of x here, and we just have x times 0.1 plus, and now y is 10 minus x, so we have 10 minus x multiplying 0.4. That should be equal to, and this is 2.5 pounds of peanuts. All right, so to solve for x, we now need to solve for x. To do that, just multiply this out. So we have, let me say, 0.1x plus, and we have 10 times 0.4, so that's just 4, minus x times 0.4, so this minus 0.4x. That should be 2.5. Now we leave x on, x is on the left, and move everything else to the right. So we have 0.1x minus 0.4x equals 2.5. When we move 4 to the right, we have minus 4. Now 0.1x minus 0.4x, that's minus 0.3x, and that should be 2.5 minus 4, that's minus 1.5. All right? So x is going to be minus 1.5 over minus 0.3. By the way, if you got at this moment that this number is negative, you immediately know something's wrong, because the meaning of x is the amount of peanuts that comes from mixture 1, the amount of peanuts in that 10 pound in 10 pounds of 25% mixture. So you know that x should be number of pounds, so that should be definitely a positive number. So definitely if you get x being negative, something's wrong. But here we have two minuses, so we have 1.5 divided by 0.3. And if you think what that is, you can write it as, so the question is, what number multiplied by 0.3 will give you 1.5? Well, it's actually 5. So you can see that this is 5, because 5 times 0.3 is going to give you 1.5. Okay, so x is 5. So for this one, we didn't need to calculate. All right, are we done? No, we are not, because we still have to find what y is. And the total amount of mixture should be 10 pounds, and since x is 5, you see that y should be 10 minus x, so that should also be 5. And now you see, now you say, wait a second, x is 5, y is 5. So I contribute with the equal amounts from first and second mixture. Well, does that make sense? Well, it would make sense if 25 is exactly the midpoint between 10% and 4%. So when taking these two of the same amount, when you have a mixture, the mixture will give you the average of 10 and 40. Well, how far is 25 from 10? Well, it's 15. And how far is 25 from 40? Well, it's again 15, but on the other side. So you could have figured out this problem even though you don't know anything about systems of two equations with two unknowns. So that's only because 25 is exactly the midpoint in between 10 and 40. So it's just a common sense that you need the same amount from each mixture, all right? But in some other problems, if you want, let's say, 30%, then it's not so, the answer is not so immediate, and the procedure is still the same. So let's see one such example where it's not the midpoint but something else. Okay. So problem 8, blending granola. Problem number 8 at the back of the book. At the back of the section. Deep thought granola is 25% nuts and dried fruit. Oat dream granola is 10% nuts and dried fruit. How much of deep thought and how much of oat dream should be mixed to form a 20-pound batch of granola that is 19% of nuts and dried fruit? Okay, so here is deep thought and oat dream. Deep thought has 25% of nuts and fruit. Now it should be clear that actually you should not separate fruits and nuts, dried fruits and nuts. It's just one component. You can treat it as a one component, and 25% of that component is in deep thought, and 10% of OD, oat dream, consists of nuts and dried fruit. Okay, and we want to get 20 pounds of 19% nuts and or 20 pounds of mixture which has 90% of nuts and dried fruit. Okay, so again, let x be the amount of dt, so the amount of pounds, so how many pounds of dt is in this 20-pound mixture, okay? And y is the amount of oat dream, the contribution of oat dream in this total of 20 pounds of this 19% mixture. Okay, so again we have to set up requirements. So one requirement is that the total sum of these two amounts should be 20 pounds. So x plus y should be 20. Now we also have another requirement that the mixture that we get by mixing x pounds of dt and y pounds of OD we should get 19% of nuts and fruit, nuts and dried fruit. Okay, so how much fruit, nuts and fruit do we have in this 19% mixture if we have 20 pounds of that? Well, we get 20 times 19% is 0.19. So this is amount, pounds, how many pounds of nuts and dried fruit are there in the 20 pound mixture. Now that's on one hand. On the other hand, we can separate the amount of pounds of nuts and dried fruit that is contribution of DT granola, and the amount of pounds of nuts and dried fruit which is a contribution of OD granola. Okay, so if you have X pounds of DT granola in this mixture, the contribution of nuts and fruit that comes from DT granola is X times 0.25. Simply, it's just if 25% of DT is nuts and dried fruit, that means 1/4 of the amount is nuts and dried fruit. So if we have X pounds of DT, then 1/4 of X is going to be the amount of nuts and dried fruits which comes from DT granola. And similarly, the amount of fruits, nuts and dried fruit that comes from OD granola is Y times 0.1. 0.1 is 10%, so it's the same thing as Y over 10. So 1/10 of the total amount goes on nuts and dried fruit, okay? Which is the contribution of OD granola. So the total amount of nuts and dried fruit, this is the total amount that is a contribution from DT granola. This is the amount which is a contribution of OD granola. So the total amount is actually the total amount of nuts and dried fruit in that 20 per pound mixture, which contains 19% of nuts and dried fruit. So these are two requirements. And again, we can solve by substitution. From here, we get that Y is 20 minus X, and we plug that in here. So we have 0.25X plus, and then we have 20 minus X multiplied by 0.1 should be, or actually let me write that here. Well, I will keep X times 0.25 plus Y, which is 20 minus X times 0.1 is equal to, and now when you multiply these two, that's what, 3.8, right? Okay, so let me just double check. It's the same thing as 2 times 1.9, yeah, so that's 3.8. So this is what we have. We want to find what X is, so we distribute this. So we have let me keep like this. X times 0.25 is 20 times 0.1, so that's 2, minus X times 0.1, so it's minus X times 0.1. So we distribute this, and that should be 3.8. Now, just like we did with any linear equation, to solve for X, make all X's be on the left and the rest on the right, and I should have here plus, right? So we just need to move 2 to the right, or in other words, to subtract the equation by 2, subtract 2 from this equation. So we have 0.25x, and we have minus 0.1x. That's going to be equal to 3.8, and when we move 2 to the right, we get minus 2. Okay? Now, what's 0.25x minus 0.1x? Well, it's just 0.15x, right? So 0.25 minus 0.1 is 0.15, so that's why we have that on the left. On the right, 3.8 minus 2, that's 1.8. So we have that x is, to solve for x, you just need to divide by 0.15, and you get 1.8 divided by 0.15, and let me use the calculator. Just a second. So what do we need? 1.8 divided by 0.15, that's going to be 12. All right, 12. Okay, and that's x. Now what is y? Well, this is the amount of DT granola in this 20-pound mixture, so we need 8 more to get 20, so that's what you get from here. So y is 20 minus 12, so that's 8, all right? That is 8. So x is 12 and y is 8. 12 pounds and 8 pounds. So we need 12 pounds of DT granola and 8 pounds of OD granola, so that when we make a mixture, it's going to be 20 pounds of 19% of nuts and dried fruit. Okay? And let's see one more example, number 10. Problem number 10 from the back of the section 8.4. So it says, it's called livestock feed. Soybean meal is 16% protein and cornmeal is 9% protein. So soybean gives, what did we say, 16% of protein, and cornmeal gives us 9% of protein. And suppose you have some, I don't know, cows or pigs or whatever, and that need 12% protein mixture, okay? And suppose you need 350 pounds of that. So we want 350 pound mixture with, what did I say, with the 12% of protein. Okay, so how are you going to find how much of soybean and how many pounds of soybean and how many pounds of cornmeal should you have to get 350 pounds of mixture which has 12% of protein? Okay, so again, let x be the amount, so in pounds, amount in pounds of soybean, the amount of soybean in this mixture, and y is the amount of cornmeal. Okay, in pounds again. So I just need you copy. Okay, so we want the total to be 350. So the sum of the two we want to be 350. That's one thing. The other requirement is related to the percentage of proteins that we want. So if you have 350 pounds and 12% of that goes on proteins, that means in total how much pounds of proteins do you have? Well, you have 350 times 12%, which is 0.12. Now, on the other hand, you can calculate what the contribution in terms of pounds of protein comes from. Comes from soybean, and what number of pounds of proteins is contributed by cornmeal. So soybean contribution is going to be, if you have X pounds in this mixture and you have 16% pounds of 16% of proteins in these X pounds. So in total you have X times, I should actually write 0.16 pounds of proteins that come from soybean. Now, as far as the contribution of cornmeal, you have Y pounds in this mixture, Y pounds of cornmeal, and 9% on that goes on protein. So in total you have Y times 0.09, so 0.09, so 0.09 is multiplied by Y is actually the amount of pounds that come from the amount of proteins in pounds that come from cornmeal. So these are two equations, and you just need to solve to find what the amounts X and Y are. So again, you can use substitution. So Y is 350 minus X, and that we conclude from this equation, and we plug that in here. So we have X times 0.16 plus, and Y is this, so 350 minus X multiplied by 0.09. That should be equal to 350 times 0.12. Okay? Now we distribute this, so we have X times 0.16 plus this times this minus this times that. So we have 350 times 0.09 minus X times 0.09. That should be, no, that should be, okay, I will write 350 times 0.12. Now, let me just compute these two numbers. So I will write 0.16x plus, and this thing here is, maybe it's faster to compute manually by hand. So 350 times 0.09 is 31.5 minus, and we have 0.09x is equal to, and this thing is 42. This product is 42. Now I leave x's on the left and move the rest on to the right. So I have 0.16x minus 0.09x is equal to 42 minus 31.5. Okay, so now 0.16 minus 0.09, that's 0.07 x. That should be 42 minus 31.5. That is 8.5. Okay, so x is 8.5 divided by 0.07. And let me use calculator to see what this is. This is 8.5 divided by 0.07. That's 121.43 approximately. So this is x is approximately 140. What did I say? 121.43. Yes, 0.43 approximately. So y should then be demanded me to get 350. So y should be 350 minus 121.43. So y should be, this is again approximately, it's not exactly, but it's accurate enough. So this is going to be what? Well, it's going to have 0.57 and 122 we need 8 to 130 and we need 20 to 50 and we need 200. Okay, did I get this right? 7 3 1 8 1 0 1 2 and 2 4. So n plus 1 is 5. Yeah, I think this is okay. So we need 121.43 pounds of soybean and 228.57 pounds of cornmeal to get 350 pounds of 12% protein mixture for cattle, for whatever animals we have. Okay, and now we'll continue and we'll discuss section 8.5, which is about solving a system of 3 linear equations with 3 unknowns. Okay, so let's take an example 1 from the textbook, and it says x plus y plus z is 4. That's first equation. X plus y plus z is 4, and x minus 2y minus z is 1. So x minus 2y minus z is 1, and 2x minus y minus 2z, 2x minus y minus 2z is equal to -1. Now whenever you write a system like this, so we have 3 equations and 3 unknowns. Whenever you write a system like this, it is much better, not just that it's much more pleasing to an eye, but also it's better in the sense that it reduces chances of making a mistake if you write x's one below the other, and if you write y's below each other and one below other, and if you do the same thing with z or z's. All right. So how do we solve the system of three equations with three unknowns? So there are examples in real world. We'll see some of them that need these kinds of mathematical models with three equations and three unknowns. So to find the solution, that means to find a triple x, y, z that satisfies all the three equations. Now, in terms of types of solutions, if you had two equations and two unknowns, you could think of them as lines, and you can have parallel lines, which means no solution. You can have intersecting lines, but that means exactly one solution, exactly one pair x, y. But you can also have overlapping lines, so infinitely many solutions along the line. Now, the situation in this case is similar but more complicated, and we're not going to discuss that. I just want to tell you that there are situations where you can have no solution, you can have exactly one solution, or when you have infinitely many solutions, but now what do we mean by infinitely many? It can be along some line in 3D, or it can be the set of all solutions to be a plane in 3D. But we are not going to discuss that. So we are just going to see examples where there is no solution, or where there is exactly one solution. Okay, so how do we solve that? Well, here is the strategy. If you remember, in the system of two equations, solving by elimination, you multiply the equations by appropriate numbers, and when you add them up, you lose one of the variables, and only one survives. So, and you can get, and in that way you get one equation with one unknown. So if we try to do the same trick here, it doesn't work immediately. So, for example, if you take these two equations, you can eliminate, let's say, x. But the problem is, if you eliminate x, you have two remaining two remaining unknown variables. So what you will get is one equation from these two, but with y and z. Okay, so that's actually not so bad, but it doesn't solve problem immediately. So, but okay, let's see. How do we eliminate x by looking at these two equations? So we have x plus y plus z equals 4, and x minus 2y minus z equals 1. So I'm just going to pull these two equations over here, and now I want to eliminate x. So to eliminate x, it suffices just to multiply, let's say, first equation by -1. And so what do we have? Instead of this equation, when multiplied by -1, we get minus x minus y minus z. That's what we have on the left side. And 4 times -1, that's minus 4. That's what we have on the right side. So that's first equation. Second equation, we just copy. And actually, solving system of equations, if you want it to be written in the way so that you reduce chances of making a mistake, you have to copy or rewriting a lot of time. So you see, this is nothing new. This is just these two equations copied. The second equation here out of these two is nothing new. This is just this equation copied. And we will keep doing that all the time. So when you see at the end there is a lot of work, actually most of it is just copied. Okay? So not so much of math. So now we add these up. And minus x plus x is going to be 0 axis, so it's just 0. And minus y minus 2y, that's going to be minus 3y. Minus z, that's minus 2z, all right? That's what we have on the left side. So if left side here is equal to right side here, and left side here is equal to right side here, so the sum of the left sides is supposed to be equal to the sum of the right sides. The sum of the left sides is this, and the sum of the right sides is minus 4 and plus 1, so that's going to be minus 3. So we get equation minus 3y minus 2z equals minus 3. So if x, y, z is a triple that satisfies all these three equations, it has to satisfy in particular these two equations. And when you multiply the first equation by -1, nothing changes in the sense you don't change solution, so you are still looking for the same x, y, and z. And when you add these up, you get the equation where only y and z appear. So if x, y, z is supposed to be a triple, which is the solution of this system, in particular, it has to satisfy, or at least its y and z components have to satisfy this equation, all right? So it looks like we didn't get anywhere because you cannot solve for y or so. I mean, if you want to try to solve for y, we'll have to express y in terms of z. And if you try to solve for z, you will express z in terms of y. So you don't get exact value of y and exact value of z. So you may think this thing, this elimination trick, which worked when you had two equations with two unknowns, doesn't work here. And the reason is because you have too many unknowns. Well, it is true that because you have three unknowns, you get from two equations, you get the equation in which two unknowns appear, but you also have three equations, so you have more equations. Although you have more unknowns, you also have more equations. So now, if you, there is nothing particular about first and second equation. Now you can take some other pair of equations, let's say first and third equation, and do the same procedure, eliminate x, and now since this guy is some new information, not hidden here in general, that means you may expect to get some other equation in which y and z appear. So that's the strategy. So again, apply elimination system, elimination strategy, but now using other two equations. So let's say first one and second. So this was the first equation, this was the second equation. Now let's take first equation and third equation. Okay? So the first equation, now again I'm copying, so this step is just copying. X plus y plus z equals 4, and x minus 2y minus z equals 1. Oh, sorry, I just copied the second equation. I need 2x, I need third equation. 2x minus y minus 2z equals -1. All right. Now, let me multiply. Let me see whether this is visible. Okay. Let me multiply the first equation by some number so that when I add these two equations, I will eliminate x again. Okay, so to do that, I need to multiply by -2. Okay. So I multiply first equation by -2, and I get minus 2x minus 2y minus 2z equals 4 times negative 2 is negative 8. And I again copy the the second equation here, which is the third equation over there. So I have 2x minus y minus 2z equals negative 1. Okay? Now we add up. Remember, the reason why we multiply by negative 2 is because we wanted, when adding up, we wanted x to disappear. And it really does. Minus 2x plus 2x, that's going to be 0x. Minus 2y plus negative y, that's going to be negative 3y. Negative 2z plus negative 2z, that's going to be negative 4z. That is, and on the right side is negative 9. That is equal to 9. Negative 9, sorry. Now we get another equation in which y and z appear. Now note the key point here is that in both pairs, for both pairs of equations from this system, we eliminated the same unknown variable. So by eliminating x here, we got equation in which only y and z appear. Here we again eliminated x and got some other equation in which y and z appear. So now you have two equations in which only y and z appear. And actually you reduced problem to the previous sections, a problem of solving a system of two equations, linear equations with two unknowns. So now we reduced problem to finding y and z for which these two should be satisfied. So minus 3y minus 2z equals negative 3. That's one equation. And the other one is negative 3y, negative 4z should be negative 9. Okay? So if x, y, z is a triple that satisfies all these three equations, then in particular y and z coordinates have to satisfy this, and also y and z coordinates have to satisfy this. Okay? And so we need to solve this system. We know how to do it because this is the topic of previous sections. All right? So we should be able to find y and z. Once you find y and z, then use either of these or these equations, and so and find the x by plugging in what the y and z by plugging in values y and z that you got from here. Okay, so that's the strategy. All right, so we are halfway through approximately, or maybe closer to the end than to the beginning. So now we want to, let's say, eliminate what? Let's eliminate y. So to do that, you multiply first equation by negative 1, and instead of copying, instead of writing what you get when multiplied by negative 1 and copying the second equation, let me do it immediately, just like we did in couple of last problems section about solving system of two equations with two unknowns. So minus 1 times minus 3y, that's 3y, and minus 3y, that's 0y. Actually, that's why we multiplied first equation by negative 1. So we have 0y, and we have, or okay, let me not even write that. And we have minus 2z times 1, so that's 2z plus minus 4z. So we have 2z minus 4z. That's negative 2z equals negative 3 times negative 1. That's 3, and minus 9. That's negative 6. Okay. Okay. So, well, okay. Actually, as a matter of fact, let me, since this is first example, let me not rush. So I will just write write what we get instead of first equation when we multiply by negative 1. So we get 3y plus 2z equals 3, and we just copied the second equation, so minus 3y minus 4z equals negative 9. And now we add up. Left side is equal to left side, is equal to right side, left side is equal to right side, so the sum of the left sides should be equal to the sum of the right sides. So when you add them up, you get 0y, and you have 2z minus 4z, that's minus 2z, equals 3 plus negative 9, that's negative 6. So that's what I just wrote a minute ago. Okay. And now what's z? Well, obviously z should be 3. So z is negative 6 over negative 2, or in other words 3. Okay, are we done? No, we just found what the third coordinate, z, what z is. Now what about other two coordinates? Now we can find y somewhere. You can use some equation, one of the equations here. Let's say, let's take which one? Well, let's take this one. So we have, from here, we have that 3 times y plus 2 times z, and z is 3, should be equal to 3. Okay? If so, 3y plus 6 should be equal to 3. Now move 6 to the right. In other words, subtract subtract 6 from the equation, from each side of the equation, and you get 3y equals 3 minus 6, which is negative 3. So y is negative 3 over 3, or y is negative 1. So we got y, we got z. Are we done? No, we still have x to find. And how do we find x? Well, go back to any of these equations where x appears. You obviously can't go here because there is no x here. But let's take this one, or that's the first equation that we have in this list. So we have x plus y, and y is negative 1, plus z, and z is 3, should be 4. And just find x. So minus 1 plus 3 is 2. So x plus 2 is 4. And so x is, so when you move 2 to the right, you have 4 minus 2, and that's 2. That's your x. Okay? So now you see, let me erase this. Now you see that the triple x, y, z should be x is 2, y is negative 1, and z is 3. Okay. Now, are we done? Well, we are done, but there was a lot of work here, so there might be possibility that we made a mistake. Now, one way to check whether you made a mistake is to go over step by step, go back to all the steps, and go step by step and see whether every step is correct. But there is independent way and more efficient way to check, and since it's independent, that's why it's more efficient, to check whether this triple 2 minus 1, 3 satisfies all these equations. Well, just simply plug in 2 for x, negative 1 for y, and 3 for z, and check whether all these three equations are satisfied. So let's see the first one. X is 2, so we have 2, plus y is negative 1, plus z, so plus 3 should be 4. Is this true? Well, 2 minus 1 is 1, plus 3 is 4, so 4 is really equal to 4. So does this show that we really got it right? Well, actually, the reason why this is true is basically because we used y and z being -1 and 3 to find 2. So we used this equation to find x by knowing y and z. So it just guarantees that if y and z are correctly found, then x should be 2. But it still doesn't mean that y and z are really these guys. All right? So this is not complete checking. All right? And we need to check actually all three equations. Only when all three equations are satisfied, then you can say that, okay, I got it right. So x, y, z, 2 minus 1, 3 is really a solution. So let's check the other equation. X minus 2 minus z equals 1. So x is 2. And then we have minus 2 times y, and y is -1. Minus z, so minus and z is 3. That should be 1. Is it true? Well, minus 2 times minus 1, that's plus 2. And we have 2 plus 2, that's 4. And minus 3, that's really equal to 1. So this is also correct. Are we done with checking? Well, again, as I said, you may get x and y right based on z being correctly calculated, and you still don't know whether z is calculated correctly. All right? So, or if you first found y, then you can say x and z are correctly calculated based on y being found correctly, but you still need to check whether the first equation, the first unknown variable was found correctly. So you actually do need to check all the three equations in order to make sure that your answer is right. Now, once again, it's not necessary for you to give me checkup in the exam, but it's strongly recommended just for your own sake, because then you will be sure that your answer is correct. If your answer is not correct, if you got some x, y, and z and didn't check, you don't know whether it's correct. If it turns out it's not correct, you will lose points. So I strongly recommend you to check, and to check you need actually all the three. Now, if you are running out of time and you check only two equations, well, the odds are you probably will have the third equation right, or you probably got the answer right, but that still doesn't mean. It depends on the situation, it depends on your calculation, it depends what equations you took first, what you eliminated first, and it depends on many things. So the complete checkup involves checking all the three equations. So let's check the third equation. So 2x, so 2 times, and x is 2, minus y, and y is -1, so minus -1, and minus 2z, so it's minus 2 times, and z is 3. That should be -1. Now, is it true? So we have 2 times 2, that's 4, minus 1, that's plus 1. So 4 plus 1. 4 plus 1 is 5, and then we have minus 2 times 3 is 6. So we have 5 minus 6, that's -1. Well, that's exactly what we have on the right side. So all the three equations are satisfied if x is 2, y is -1, and z is 3. So we check that it's correct. And one more thing, if you remember, the way we solved this system was we took first two equations and eliminated x. Now, you don't have to take first two equations, because simply the order doesn't matter. Whether you will put this equation at the first place or at the third place, it really doesn't matter. So that means actually which two equations you will take first and eliminate x, it really doesn't matter. I mean, there are a lot of ways to do that. And when once you chose a pair of two equations, it also really doesn't matter whether you will eliminate x, or you will eliminate y, or you will eliminate z. However, in some situations, it is easier to eliminate x, not y. It's easier simply for the sake of calculations, all right? Or sometimes it's easier to eliminate y, not x. So, and also in some situations, maybe it's easier to eliminate z. But what strategy you should use is basically the following. If in some of the equations, some of the variables has coefficient 1, well, you should take, that means you should take that equation, and you should take that variable and eliminate that variable, okay? In this case, x here had coefficient 1, so that's why we chose this guy to be first equation, and this was the second equation, and that's why we eliminated x. And when we took another pair of equations, which we chose first and third, and again, of course, eliminated x. You could do it in some way, some other way. So just for illustration, let's do in some other way. So, but just remember that we got that x, y, z is 2 minus 1, 3. So now to illustrate that the answer, if you do in some other way, will again be the same. Let's now I have an idea. Okay, I don't have, all right. I just wanted to flip a coin, but I just realized that I don't have a coin here. Okay, well, okay, I'm going to grab it, a coin. Okay, it turned out that in my wallet I only have a penny, 1 cent, Lincoln, right? Okay, here is the thing. For the first choice of two, of a pair of equations, I chose first and second equation. Now there are other two pairs that I could choose as a first pair. So that means those are first and third equation, and if I take second and third equation, okay? So there are actually, for the first step, there are actually two remaining ways that I can make a first step in solving this, okay? So we already did 1, 2, or first and second equation. Now we can choose either first and third equation as the first pair of equations, or second and third. So which one I'm going to take? Well, let this one be chosen if we get heads, and this one if we get tails. All right. I'm going to flip a coin, and I'm going to show you, well, okay, I can flip, okay? And now I'm going to show you the side, one side of it, and the side that is that you can see is the side heads or tails, and whichever is here, we're going to choose that equation. Okay, ready? Okay, let's see, what is this? This looks like this is tails, right? So that means 2, 3. Okay, so that means I choose second and third equation. So I don't need the coin anymore. So second and third. So x minus 2y minus z equals 1, and 2x minus y minus 2z equals 1. Okay? So by flipping one, I just wanted to show you it. You can. It really doesn't matter which way you choose. So there are three ways for the first step. Three ways of choosing two pairs of equations. Now, let's play it again. First time we eliminated x. Now let's eliminate one of these, y or z. Well, again, let's say if it turns heads, it's going to be y. If it turns tails, it's going to be z. Okay, so which one I'm going to... Okay, so the one that I show you, if it's heads, it's going to be y, otherwise z. Okay. It's again tails. All right. So tails. So that means z. Yeah, that means z. Okay. Z. So we want to eliminate z. All right. So to eliminate z, we would like to multiply this one by -2 so that we'll get 2z, and when we add -2z we'll get 0 z's. Alright, so multiplying first equation by -2, we get -2x plus 4y plus 2z equals 1, and I'm going to just copy the second equation. 2x minus y minus 2z equals 1. Okay? Is that right? No. I need here -2, right? -2 times 1 is -2. Alright? Now I add them up. And when adding them up, I get 0z, that's okay. But I also get 0x. And what remains is 4y minus, so let me write 0 times x, and 4y minus y, that's plus 3y plus 0z, that's equal to -1. So 3y is -1. Okay, something's wrong. This suggests that y should be -1/3, which we know it's not true. Where is the error? Let me not waste time. I will just check. Okay, obviously the error is in copying this number here. This should be -1. Let me grab a marker's cap. Okay, so -1. So here we should have -1. So when we add these up, we get -3. So sometimes you make a mistake simply by wrong copying, and when copying, I just wrote 1, and it was supposed to be -1. Okay, but you know what? Heads and tails, second and third. Didn't we say that if it's tails, if it was tail, it was supposed to be the third equation here. So yeah, so actually I'm sorry. I promised you that I was going to write third equation if it's tails. So I should have written 2x minus y minus 2z as the first equation. Now, no, sorry, that was not the case. No, we said we had other combinations other than 1, 2. So we had 1, 3, and 2, 3. Yes, and tails was for 2, 3. Okay, I'm sorry. I need to write this back. X minus 2y minus z equals 1, and 2x minus y minus 2z equals -1. Okay, now we flipped the coin and decided to eliminate the z. So we get -2x plus 4y plus 2z equals -2, and 2x minus y minus 2z equals 1. And when we add these up, we get 3y is minus 2. again there, sorry, again I'm copying wrong. So this is -1. So we have -2 -1, that's -3, and that means that y should be -1, which is exactly what we had using, so can you see that? Yes, you can. Okay, which is exactly what we got in the previous way. Okay, y is -1. So you see, actually, here you didn't have to take another pair of equations to get the first unknown variable, and the reason for that is that you were lucky that not just when you wanted to eliminate z, not just that you eliminated z, but you also eliminated x. So that's why you were able to compute y. So y is -1. Now, if y is -1, then you can take that gift for free, that free gift, and plug that in here and here. So now you have this equation when y is -1 becomes x minus 2 times -1 minus z equals 1, and the second equation becomes 2x minus y, so minus 1, and minus 2z equals -1. So the first equation now is x, and now you have plus 2. When you move to the right, you get 1 minus 2, that's -1. So here you have x minus z equals 1, and this is minus 2, so that's -1. And here you have plus 1, so when you move to the right, you get -1. So on the right of this second equation, you get -1, that's -2. And what remains on the left side is 2x minus 2z. Okay? So this is what you have. Well, actually, I'm sorry. That doesn't give you... Sorry. That was wrong. You should not use the same two equations. So you should have actually taken... So let's still keep the first equation, x minus 2y. So minus 2 times -1 minus z equals 1. And take the other equation. So this was what? This was second, this was third. So let's take x plus y plus z. So x plus and y is -1, and plus z, that should be 4. So why shouldn't you, what's wrong with taking this one? Well, it's nothing wrong, it's just that you don't get anywhere. You get something like 0 equals 0. So you will not find the other two variables. If you don't believe me, what did we say? Y was -1, so this is 2. When you move this, you got x minus z equals -1. And we had that 2x minus 2z is, so 1 minus 2, all right? So actually, if you try to solve this system, when you multiply this one by -2, you will get that this equation will become -2z plus 2z equals 2. But now when you add these up, you get 0 equals 0. The reason for that is because you found y using these two information. So when you plug in the same y here, it's not that with this information y equals -1 that you are contributing into these two equations, because simply you extracted this information about y using these two. So basically that's an explanation why it wouldn't work in this way. So it is true that 0 equals 0, but it doesn't get you anywhere. Everything is correct, but doesn't solve your problem. Okay, so that's why if you found that y is -1 using these two, just these two equations, you should use the third information, the third equation, to find the the other two unknowns. So we have here what? We have, this is 2, when you move to the right that's -1, so you have x minus z equals -1, and -1, when you move to the right it becomes +1, so you have 5 on the right, so you have x plus z equals 5. Now this is a new information because that comes from the third equation, which has nothing to do with these two equations, all right? And the y is directly, again, y was directly determined from these two equations. So plug that in this information, you are just going in a vicious circle. Okay, so now you can just add these up and you get 2x plus z, so you are eliminating z, that's why I'm adding these two up. So 2x is equal to -1 plus 5, that's 4, which means that x should be 2. So y is -1, which is exactly what we had here, but now we have also that x is 2, which is exactly what we have here. So what remains is to find z. So let's take this equation. So x plus z, so that means 2 plus z is equal to, is supposed to be equal to 5. So from here, obviously, z should be 3, which is again what we've got here. Okay? All right. So this was faster because, simply because we, at one point, we killed 2 birds with 1 stone. In other words, by eliminating z, we at the same time eliminated z. Eliminated x. Okay, so let me see how much time. 1:41. Okay, so maybe I can stop here, and then I will decide whether there will be another makeup lecture. Probably there will, but sometime later. Okay, that'll be all for today. Take care.